Hello. Hi. Today we are going to do review problem for dimension analysis, and today's problem is this. We have a so this is the Newton's law of universal gravitation, and the formula is F is equal to Gmm by r square, where capital M is the mass, capital M and small m are the masses, and r is the length. So we have to dimensionally find out, so we have to use dimension analysis to find out the proportionality constant G. So what is the proportionality constant, and how do we find it out? So first off, let's start with uh, writing down all the constants. What are the dimension of forces? The dimension of all the, not the constant, but all the units that we know of. So force is the dimension of force is Newton. So the unit of force is Newton, which is nothing but kg, kilogram meter per second square. So from here you can get the idea of what is its dimension. So the dimension of force would be kilogram indicates mass, so therefore you have mass. Meter indicates length, so dimension of length, and then second basically tells you its time, it's square, and it's in the denominator, so therefore it is -2. So that is the dimension of force. What about the dimension of mass? So mass, you have two masses, so one and the capital mass and the small mass, both of them are basically masses, so therefore your mass, the dimension of mass would be just m. And then you have r square. So r square is it's the distance, so it has it's the length, so therefore it has a dimension of length, and since you have a square here, so you have to incorporate that as well. So let's write this equation dimensionally. So you have, excuse me, so you have meter. On the left hand side you have meter, length and time square, -2, and then you have G, which we have no idea what is the dimension of G, and then mass, mm, so m and m again, divided by r square, which is length square. So this is basically G m square by length square. So how do we proceed from this point on? This is by finding out G. So G, you can take it to the other side, the length, you can take it to the other side, and then you have m, so you can cross multiply basically, and then you have, so first let's write down the force, so that would be -T and divided by, yeah, so the length is in the denominator on the right hand side, so therefore it would be in the numerator of the left hand side, and mass is in the denominator of the right hand side, and therefore it will be the so it's the numerator, so therefore it should be the denominator on the left hand side. So other side, let's just say the word other side. So okay, so you have some familiarity going on here. So the new denominator mass and this one cancels out. You have one of since it's a square, you have one left, so therefore m to the power -1, and then L has a square here, so L 1 plus 2, you have 3, and then time, so time to the power -2. So that would be the dimension of your gravitational constant G. All right, and that's how you have to find out the formula, the dimensions of it. So this is okay. So you can ask me now why a constant is having some dimension. This is because sometimes we are going to give constants their own dimension, because these help balance out the consistency. So if you look at this formula right here, you can clearly see that it's not consistent. So you have a mass over here, whereas you have a mass square over here, and you have length over here, but it's length square, and it's in the denominator. So therefore these things lead to inconsistency, and then you are lacking time as well. So these are inconsistent with our inconsistent, but then we have to find a way to solve them, right? So we give our constants some dimension to tackle this problem. Okay, so the next problem is kinetic energy. Ke has dimensions kg meter square second square. It can be written in terms of the momentum p, and has a mass and mass as this formula. Determine the proper units for momentum using the dimension analysis. Okay, so okay, so we have to refer back to, we'll first do the for a part of it. So Ke has the formula kg meter square and second divided by second square. So what does that mean? So kg indicates mass, meter indicates length, and second indicates time. So therefore you can rewrite this formula as length square and then t to the power -2. So t is in second is in the denominator. So if you bring that up, you would get a negative sign in the numerator, right? So yeah, so that would be the dimension of Ke. So we need to find the dimension of p square. So yes, so we'll put that to the test here. And t to the power -2 with p square divided by 2m. Remember, 2 has no dimension, so we don't have to write. We can remove 2, and mass has dimension of mass, so therefore we can write that out, and we can cross multiply, and you will end up with p square equal to mass. So if you bring that cross multiply to the other side, you will have mass, and you also have a mass over here, so mass times mass. So that kind of, and one second, so that multiplies together nicely, and you get square, and then you have length square, and then you have t to the power -2. So therefore we have, and if you take a square root of it, you get p to be mass, length, and time inverse. So that's the dimension of momentum. So that's kind of true, and that's how we momentum is you can check it out. You know, if you know the formula of momentum, which is mv, you will see that it is kind of true. If you want to do that, be my guest. And refer to problem 5. Given the unit of force, write a simple equation relating a constant force exerted on an object, an interval of time t during which the force is applied, the resulting momentum of an object. Okay, so given constant force exerted on an object on an interval of time t during which the force is applied, the resulting and the resulting momentum. So we have to write an equation relating to that. So we know that force is mlt to the power -2, and we know that momentum is tlt to the power -2. So we can write, so force, force, and somehow we have to write, we have to incorporate T. So I'm going to just put up a bracket. I'm not going to write a formula. So how do I represent my force? And momentum. So simple. We have to find out. So we know that these are the components of equation. So we have force, we have momentum, we have time. So we have to find a relationship between all three of them, which makes the dimension analysis consistent. So therefore you have mass, length, and that's the dimension of force. And then momentum, the dimension is m, L, and t to the power -1. And so since you have to make it consistent, you have -2 here. So again, so we have to introduce a t to the power -1. So therefore negative, these two become t to the power -2, -1 and -1, they add up together to become -2. So this is the only way of saying the, yeah. So we can, yeah, in another way you can say, you can see that as a split of t to the power -1. This would be the momentum, the dimension of momentum. So therefore I'm going to write that down as momentum, and this is the dimension of time. So I'm going to write that as t to the power -1, because we have a -1 over here, and then we have so p by t. So the formula then becomes, force is nothing but t momentum divided by time, which is consistent and which is also true. So yes, left. I hope you understood the formula, and I hope you understood the problems that we did as of now. If you have any questions, suggestions, or any doubts, you can always write it down on the comments below, or you can mail me. I will put my email ID in the description box below as well. And have a good day then. Bye.